Welcome back. All right, we're going to start chapter 7 now, and our chapter 7 is other applications and extensions of the integral. And today's lesson is on 7.1, is on the improper integral. Is when either, number 1, the limits of the integration a and b are both finite, or 2, the function is continuous from a to b, are not satisfied. Then it's improper. So when one of these two are not satisfied, it is an improper integral. So we're going to learn about improper integrals, and we're going to start by an example. Find the area under the graph of f of x equals 1 over x squared. To the right of x equals 1. So the first thing I did was draw a picture. Here's 1. Well, 1 over x squared is a nice little exponential that goes down. And to the right of 1 goes on to infinity. Does it ever end? It never ends. So it goes on and on. So is it continuous? It's a continuous curve, but it never has a finite stopping both sides. So where it goes is from integral from 1 to b, they call it b in this case, of 1 over x squared dx, and you'll be able to graph that. So I took it to x to the negative 2. I integrated it, x to the negative 1 over negative 1. I changed that to negative 1 over x from 1 to b. Now we don't know what b is, because b is something forever. So negative b 1 over b minus negative 1 over 1 makes negative 1 over b plus 1. This indicates that the limit of b is going to infinity, because it never ends. So now you're going to bring back the limits signs that you had in previous chapter. So the limit of b to infinity of negative 1 over b plus 1. You place infinity into the b, you get negative 1 over infinity. Who can remember what negative 1 over infinity, or negative 1 over a very big number was equal to? Well, that was 0, because like 1 over a million is 0.00001 plus 1. So if you put 1 over a very big number plus 1, you're going to get 1 unit squared. So you still can find an answer, even though it goes on to infinity, which really gives us to some other rules. So the improper integrals rules have two things. From a to infinity of f of x dx is the limit as b goes to infinity of a to b of f of x dx. So that's the one we just did. Or it could be from negative infinity to b of f of x dx, so that the a is the negative side, so it's going to go negative infinity the other direction at where you started, from a to b of f of x dx. So I'll give you a minute to write those two down. And then I'll go on to the next example. Oh, your favorite, it's an e. Find the value, if there is one, of the integral from negative infinity to 0 of e to the x dx. So I integrate e to the x. The integral of e to the x from negative infinity to 0 is e to the x. I put the top number in first, e to the 0, minus the bottom number, e to the negative infinity. E to the 0 is 1. Negative infinity means I'm supposed to put it on the denominator. 1 minus 1 over e to the infinity. E to the infinity must be a very big number. And a very big number up there was 0. So 1 over a very big number is 0. So what's 1 minus 0? That's 1. Now that's if it was on the denominator, or the lower number, my bad. If it's on the upper number, 1 to infinity of 1 over x dx. Another one of your favorites, the natural log. The integral of 1 over x is the natural log of x from 1 to infinity. So I put my numbers in, natural log of infinity minus natural log of 1. Well, I know what the natural log of 1 is, that's 0. But what's the natural log of infinity? Well, it's supposed to be a very big number. So the natural log of infinity is infinity. But what I haven't told you, and I'm going to tell you here in a minute, is anytime you get infinity as an answer, the answer is really no value. So on an answer test, you would write infinity, comma, no value, because it's very big and you don't know the value of it. What if either and a or b are not infinity and a and b are real numbers? Then the integrand could be discontinuous at either a or b, which is another way to make an improper integral. So we're going to cover that one on the next board. I'll let you look at this for a minute more. So far on this board, we've had an infinity at one end or the other end on all of our problems. Let's see what happens if infinity is not at either end. Good job. So here we are. Evaluate 0 to 4 of 1 over the square root of x dx. So that's the same thing as the limit of t going to 0 from the right. Because if I graph this, I get 1 over x, it's going to be t from 0 from the right. The integral of x to the negative 1/2 dx. So it says, note, the domain of the original problem is x cannot equal 0. Let me let you write that. I'm going to check to see how we're doing. Okay. So you have to know your domain, so that's why it says t has to go from 0 to the right, because the domain says it can't be at 0. So this is instead of a bracket from 0 to 4, it's parentheses 0, comma, 4 bracket. So 0 to the right. So I can still integrate this, though. I can add 1. I get x to the 1/2 over 1, reciprocate it 2. So 2x to the 1/2 over 1 from 0 to 4. Now remember, 0 technically can't go in there originally, but can it go in there in the problem at this point? Let's try. So I put 2, x to the 1/2 means the square root of x. So I take 2 times the square root of 4 minus 2 times the square root of 0. Well, 2 times the square root of 4 is 2 times 2. 2 times the square root of 0 is 2 times 0. 2 times 2 is 4. So you can still have that problem, even though it wasn't all there to start with. All right, so what's another way of stating this? Okay, is if it's coming from the directions of left and right, they like to make definition of that. So an improper integral, if f is continuous from bracket a comma to b parentheses, but is discontinuous at b, so this is if it would have been discontinuous at the top number, then the integral of a to b of f of x dx is the limit of t going to b from the left. So if it's on the top that you have the parentheses, it's from the left. A to t f of x dx. Provided this limit exists and a real number, the limit does not exist and is infinite, then the integral of a to b of f of x dx has no value. So again, remember in the last problem when we got infinite, it is no value if it has an infinite answer. Now, what if the bracket or the parentheses is on the left? If f is continuous on parentheses a to b bracket, so it's on the left side, it cannot be included. For instance, this was on the left with the 0 here. But discontinuous at a, then the integral of a to b of f of x dx, the limit of t going from a to the right, which is what we did up here, of a to b of f of x dx. Provided this limit exists and is a real number, if the limit exists, does not exist, or is infinite, then the value is no value. All right, I'll give you a minute to write down that. So let's go on to our last example. Find the area between the graph of f of x of 1 over the cube root of x, that is a cube root there, if you can't read it, and the x-axis from x equals -1 to 0. So I drew a beautiful picture here. So that graph is going to go this direction because it's a cubic, and it's from -1 to 0. So this is the space or the area that I want to find. But now, can I put 0 into that denominator again? No, the domain is x cannot equal 0. So you can't have 0 in the denominator, so you're going to have a 0 at one end. So that's the end you're going to have the variable. That's the end that the parentheses would be at. Now you still can find the answer. Don't think you can't find an answer. You can find the area of that. That's going to be some area. So I rewrite my problem as the limit as t approaches 0 from the left from -1 to t of x to the -1/3 dx. Sorry, I started integrating up there. So the red is the problem. I'm going to integrate x to the -1/3. I add 1, I get x to the 2/3. I put 2 on the bottom, I reciprocate it to 3 on the top, so 2/3 is reciprocated. But I still have a limit of t going to 0 from the left. I note that it's going from -1 to t. So you put t in first, I get 3t to the 2/3 over 2, minus 3 times -1 to the 2/3 over 2. I decided to pull out the 3/2 because I still have this limit as t approaches 0 from the left. So 3 over 2, as t approaches 0 from the left, minus 1. I put in 0. 0 minus 1 is -1, times 3/2 is -3/2. But I have a question. Were we trying to find the area? Can you have negative area? No, you can't. So you always absolute value your answer, or you know if it's under the x-axis to start with, it's always a negative or going to be a negative, and you have to make it the opposite. Okay, so area under the graph needs to be absolute valued in the answer. So positive 3/2 units squared. Your assignment tonight is 7.1, page 489, 135, 7, 9, 11, 14, and 15. All right, hope you understand that. I'm going to put it down and shut off the phone. Thank you.